After watching both parts of the Avatar movie, surely everyone is impressed by the massive spaceship capable of flying between the stars, right? This ship is truly massive and impressive. It's called the ISV Venture Star, or simply the ISV. This is one of the 10 most advanced spacecraft of humanity, capable of interstellar travel. It belongs to a transport system dedicated to carrying supplies, equipment, personnel, refined minerals, and data between Earth and the moon Pandora. Designed specifically for operations in deep space, it is completely incapable of landing on the surface of the planet Pandora. It launches smaller vessels, called Valkyries, similar to shuttles, to land on the moon's surface or deploy landing modules known as sling loads. It can carry a significantly larger volume of cargo on the surface compared to the Valkyrie. The ISV Venture Star arrived at Pandora after a journey of over 5 years from Earth, carrying 200 passengers preserved in cryosleep throughout the voyage. Interstellar spacecraft like the ISV Venture Star require the use of unodinium during construction, as this element plays a critical role in preventing reactions between matter and antimatter. ISV Venture Star is a spacecraft of the Capito Star class. The ISV Venture Star and the Capito Star class ships have at least one predecessor, which was 4 times larger than the current design. It is possible that ISV Bradbury is one of them. Currently, there are a total of 12 cargo ships transporting goods and crew between Pandora and Earth. Among them is the Capito Star class ship, the same type as the ISV Venture Star. The initial funding required to build the ship was assessed by ODA as a significant risk, but this risk was eliminated thanks to their exclusive unodinium mining rights. The ISV Venture Star has been operational for at least 77 years and first arrived on Pandora in 2084. Over the past decades, the ship has made numerous trips to Pandora and back, including the journey that brought Rex Sully to Pandora from 2148 to 2154. The ISV Venture Star can fly from Earth to Alpha Centauri, 4.375 light-years away, in just 6.75 years. The process begins with an initial acceleration phase lasting 5.5 months at 1.5 grams to reach 70% the speed of light. After that, the ship continued moving at that speed for 5.8 billion years before using its engine or photon sails to decelerate. The spacecraft's deceleration phase lasted 5.5 months with an acceleration of 1.5 grams. The notable point is that time dilation at high speeds would make a journey lasting 6.75 years in Earth time significantly shorter when traveling at 0.7 times the speed of light. According to Einstein's theory of relativity, the crew would only experience 5 years of travel due to time dilation. The ISV Venture Star is equipped with various propulsion systems, all of which operate throughout the interstellar journey from Earth to Pandora. Consists of 2 matter-antimatter engines, a photon sail, and a planetary motion engine, PME. The photon sail is used to accelerate toward Pandora by absorbing photons from a laser beam emitted from Earth. The ship's antimatter engine was activated to decelerate as it approached the planet Pandora, after which it would continue its journey for the final 7 million kilometers. This sequence will be reversed to return to Earth. When close enough to Pandora or Earth, the planetary motion drive will activate to place the ship into a low Delta-V orbit, from which the Toivan-Curie shuttle can be deployed to the surface. To travel quickly between the solar system and other star systems, an interstellar vehicle requires an enormous thrust to achieve the necessary speed. It took humanity roughly 200 years to develop advanced matter-antimatter-based technological systems. The ISV Venture Star is equipped with 2 symmetrically positioned antimatter engines, designed to propel the ship backward. The engines are angled slightly away from the hull, tilted a few degrees off the longitudinal axis, so the exhaust jets do not affect the ship's structure. In this case, the antimatter used is anti-hydrogen, stored by a magnetic field in an environment of near-perfect vacuum. It spreads as an atomic cloud, cooled from a high altitude down to a temperature near absolute zero. When antimatter and matter come into contact, they annihilate each other and release an enormous amount of energy. This energy flow is controlled by an extremely powerful magnetic field, forming a jet stream. Although these photons have no mass, they still carry momentum, and emitting them generates thrust that accelerates the spacecraft. The additional thrust is generated by injecting hydrogen atoms into the plasma before they escape the engine. That object is extremely hot and shines over 1,000,000 times brighter than the arc beam emitted by a standard welding machine. This jet stream stretches over 30 kilometers and is considered one of the most impressive man-made wonders to date. The ship's main framework can only remain stable in a zero-gravity environment. The front section of the train includes the engine, fuel tank, and radiator. Next is the propulsion system. Though thin, this material is rigid enough to prevent the payload section from warping due to resonant vibration buildup during acceleration and deceleration. The section of the manifold in contact with the antimatter engine's nozzle is protected by a heat shield made of a material with near-perfect reflectivity to protect against the intense heat radiating from the exhaust pipes. Tuesday, the shipping containers are arranged in 4 rows, each consisting of 4 modules. These 16 modules consist of 6 compartments specifically designed for cargo transportation. Depending on the cargo hold configuration, the contoy ship can carry 2 supply compartments along with 100 passengers, or a maximum of 6 cargo holds but no passengers. A rail-mounted transport vehicle can operate a large robotic arm, facilitating the movement of cargo modules to and from the contoy atmospheric landing ships. Wednesday, there were 2 Valkyrie landing ships. Fifth, the residential area consists of 3 main modules, including a freezer and an amnio tank. Inside each module is a monolithic structure made from high-grade composite material, with non-load-bearing partitions constructed from composite foam, using almost no metal in the structure. The purpose of this is to prevent cosmic radiation from the galaxy from striking the metal, thereby limiting the generation of secondary radiation particles. Some air chambers are specifically designed for the crew, while the repair robot docking ports resemble high-tech mechanical crabs. Friday, immediately following these 3 modules are 2 crew duty modules located at opposite ends of the crossbeam. In travel mode, these modules can rotate to generate artificial gravity, making it easier for the crew to work. During acceleration and deceleration, the modules will fold along the ship's longitudinal axis. In this configuration, gravity is generated by the ship's acceleration, ensuring that every floor and partition is always correctly oriented in the direction of gravity. The modules also generate artificial gravity throughout the year-long journey of the ISV Venture Star orbiting Pandora. And finally, in the distance is the white incense shield, tasked with protecting the ship from the intense beam of light emitted by the super-energy laser shining up from Earth. This layer is only a few molecules thick but can effectively reflect light, protecting the spacecraft's path from being burned. When the acceleration phase ends, the ship rotates 180 degrees to position the shield facing forward. The shield assumes another role, acting as a protective barrier against dust and debris among the stars. Although a strong magnetic field is used to guide stray gas molecules, dust particles sometimes still require a direct physical impact. The white leaf has many layers, each spaced 100 meters apart. The dust particle, moving at a relative speed, 0.7 times the speed of light, evaporates and turns into plasma upon colliding with the first layer of the white plate. The plasma particles shot out and struck the second layer, creating an impact that caused the backside of this layer to crack and shatter. These particles are blocked at the third layer. The fourth layer serves as a backup, in case anything slips through the third layer. All consumable supplies are recycled to the greatest extent possible. Oxygen is extracted from the air through fractional distillation, while completely removing gaseous pollutants. Additionally, this process removes water vapor and purifies it into safe drinking water. A steam distillation unit is used to extract additional drinking water from urine and solid body waste. The remaining material after dewatering and sterilization is repurposed as fertilizer for hydroponic gardens, where fresh vegetables and fruits are grown to supplement the crew's primarily freeze-dried food diet. Orbit or Pandora, all passengers and the entire crew did not enter hibernation. Maintaining this condition throughout the trip is hardly feasible. When the hibernation system fails, the passengers will die before they can wake up, allowing the crew to continue the mission and complete the cargo delivery. The ISV Venture Star can carry 350 tons of cargo. When returning to Earth, most of the ship's cargo consists of refined unobtainium. There are also small Navi artifacts sold as collectibles, but they are extremely expensive, only for those who can afford them. Sometimes, the molecular structure of organic compounds on Pandora can be transferred to Earth for applications in medicine or other fields. The plant samples were also brought back to Earth for research purposes. The ISV Venture Star represents the pinnacle of humanity's most advanced technologies, designed to travel between star systems in the shortest possible time while ensuring crew safety and cargo integrity. With its extremely high speed, the ship risks being destroyed if it hits debris larger than a grain of sand. Although the probability is low due to most of space being empty, many believe there is still a chance of collision during the spacecraft's operational period. To prevent disaster, one had to consider many complex factors, thereby creating convoluted systems that made the entire structure even more complicated. Like an incense shield, the protective magnetic field along with other physical barriers all face forward, while the laser system is capable of targeting and eliminating obstacles. Another risk is gamma radiation produced when small particles collide with the shield. These gamma rays are produced by particles moving at extremely high speeds, nearly the speed of light, relative to the spacecraft. If the ship accidentally enters an area with dense dust concentrations, crew members on duty could receive a lethal dose of radiation. People in hibernation states have better radiation resistance. In this case, the automatic sensor system will wake another group of crew members from hibernation once radiation levels have dropped to a safe threshold. Clearly, although the ship is a product of science fiction, it is essentially a highly promising design that could very well become a reality in the future. And of course, we can't forget Uno Tani Rangjia.